In section 4.6, we want to extend our discussion of polynomials to complex polynomials. A complex polynomial is just a polynomial that has complex coefficients. All of the polynomials we have seen so far have been complex polynomials because a real number is also a complex number. So we just have this new definition where we let the coefficients be complex numbers. So then if we have a number where we can evaluate that x at that number and we get 0 for the polynomial, then r is called a complex 0. Really, we're not adding anything new in terms of what we're going to do, but it is more general theoretically. So what good does this do for us? Well, we have what's called the fundamental theorem of algebra. And the fundamental theorem of algebra says that every complex polynomial function of degree n greater than or equal to 1 has at least one complex 0. And every complex polynomial function of degree n greater than or equal to 1 can be factored into linear factors. And that's a big deal. So what we're saying is that we can rewrite our polynomial as a bunch of x minus r's, where each of these r's are the zeros of our polynomial. This is pretty much what we did in the last example. We tried to factor our polynomial into linear factors. One thing that we should know when dealing with complex numbers is if we have imaginary numbers as part of our solutions, these imaginary solutions come up or turn up in pairs. So if we start off with a polynomial function with real coefficients, and if r equals a plus bi is a 0, then a new r, we're going to call it r bar, a minus bi is also a 0. And this a plus bi and a minus bi are called conjugate pairs or complex conjugates. And we actually saw this in the last example we did, where we had two solutions, 2i and negative 2i. Those were complex conjugates. So what we'd like to do is we would like to look at some polynomials, factor some polynomials, and find complex zeros for polynomials.